This is part 2 of a two-part video series in which we are investigating the beams included in the LEGO Mindstorms core and expansion kits. In this video, we will look at basic construction using the beams. In the description area below, you will find a link to a list of all the parts we will be using. You will need to have all of these pieces available to follow along with the video. Please pause the video now and get out the parts. Once you have the parts ready, restart the video for our construction experiments. I have my small dish in front of me with a brick separator in it. And now I'm going to get out the pieces that are in container number 1, which are 2 of our 15M beams and 2 of the small connector pegs with friction. I'm going to put those in my small dish so I can keep track of them more easily. Beams are the structural components of our set, and in these experiments we're going to see how we can put some of them together to accomplish different things. Now here, with our first step with our two 15M beams, we're going to see how we can turn those two beams into a longer unit. So first I'm going to take one of my connector pegs with friction and put it in the end of one of the beams. Make sure you hear a snap when it goes all the way in. And if you can see color, you might notice that I have 2 different colored beams here, but in all of these experiments, color does not matter at all. So now that I have that peg in the end of one of the beams, I'm going to take my other beam and place the end of it right on top of that peg until I hear that snap. Now I have a very long beam, and we have it overlapping by one peg, but it is not stable. If you pick up the ends of each beam and one in each hand, you see that it's very easy to bend that. So that's not very stable. If you wanted to make a longer connection and have it be stable, you take this unit apart. And if you find it hard to get the pegs out by just pulling them, use the little axle protrusion on the end of your brick separator and push that in to get that peg out. So now I'm back to having 2 of my 15M beams separate. I'm going to take one of those pegs and put it in the end, just like we did before. Now I'm going to take a second one and put it just to the left of that first peg. So the first beam has 2 pegs at the end of it. Now I'm going to take the second beam and I'm going to put the first 2 holes on that beam into those 2 pegs. Sometimes you have to wiggle it around a little bit to get them to line up. Again, make sure you push it down till you hear a little snap. Now again, let's pick up the end of each beam in each hand, and if you just gently put your thumb a little bit down on each of those beams, you'll see it has some flex. And although we have a sturdy connection, it's still kind of flexible. So one way we can resolve that is, again, let's take this unit apart. Again, have 2 separate beams and my pegs are out, and I'll put a peg in at the end of one beam, and now I'm going to skip at least 1 hole. I'm going to skip 2 holes, and then so now I have a peg at the end, 2 holes blank, and then another peg, and I have those facing towards the right. So I'm going to take my second beam, and in the leftmost hole I'll put the peg that is furthest to the left. So now we have an overlap of 4 spaces there. And this, if you try flexing that, you should see that that is not quite as flexible as it was before. Notice also that when we make this kind of connection, all of the holes are still facing in one direction. So that's the end of our first experiment. We can put these pieces back in container number 1 and get out the pieces from container number 2. In container number 2, we have an angular beam that is 4 by 6 and a 7M beam, and then we have 2 pegs. One is a peg with cross axle and one is just a plain peg with friction. So on the peg with cross axle, one end is shaped like an axle and the other end is round, and on the connector peg with friction, both ends are round. So I'm going to start with my connector peg cross axle, and I'm going to take that cross axle and I'm going to put it into the end of the 6th side of my angular beam. And just press it until it goes all the way in. And then we'll take one end of our 7M beam and put the last hole onto that peg that's sticking out. Now we have one long unit consisting of the angular beam with an extension of the 7M beam. Since we only have one peg in there, we are able to turn that 7M beam if we keep the angular beam steady. There is some resistance because it is a friction peg, but you can still turn it. Now let's see how to use the 2 pegs that we have in this container to make a more stable connection there. So we'll take this apart. I've left the peg cross axle in the last hole, so the cross is down inside of there. And now I'll take my peg with friction and put it directly to the left of that peg cross axle. So now we have 2 friction pegs sticking up at the end of our 4 by 6 angular beam. And now we'll take the last 2 holes on our 7M beam and put one of those pegs in each of those holes. And now you can see you have a nice stable extension to that piece. So anytime you have a beam that has a cross hole at the end, you can use one of the pegs that are friction cross axle in the end and then just put a peg with friction next to it, and you'll have a way to connect another beam to lengthen that unit. Now we can put these pieces away and get out our parts that are in container number 3. In container number 3, we have 2 Technic 7M beams and 3 Technic 11M beams and 6 of the little connector pegs with friction, which I've put in my small bowl. Now to start with, we only need 2 of the 11M beams and the 2 7M beams, so I'm going to put the 3rd 11M beam off to the side. Then take the 11M beams and put them horizontal on your work surface with one above the other. In this experiment, we'll be making a rectangular construction. So we'll take 2 of our connector pegs and we'll put one in each end of the first 11M beam, and then take 2 more pegs and put one in the end of each end of the other 11M beams. So you should have 4 pegs sticking up. So our unit is going to consist of the 2 11M beams being horizontal on the top and bottom, And then our two 7M beams will be vertical on the left and right sides. So we can take one of those 7M beams and holding it vertically, put the pegs that are in the ends of the 11M beam into each end of a 7M beam. And then take the other 7M beam and do the same thing on the other end. And now sitting on your table, you should have a rectangle. The short sides are vertical and they are up one level from the long sides. Now let's pick this up and put it on one of the long ends on the table, and then see what happens when you put some pressure on the top long side. The unit collapses. So we need to add some stability to that structure, and let's see a way that we can do that. One way we can do this is to add an additional beam that angles across the construction. Now we want to make sure that our unit stays nice and square with 90-degree corners. So when we put our additional beam on at an angle, we need to be mindful that we use the correct holes to keep those 90 degrees. You may be familiar with the Pythagorean theorem from math class and special triangles that are called Pythagorean triples. Pythagorean triples are triangles that have certain combinations so that there is always one right angle. One of the simplest ones is a 3-4-5 triangle, which means if you have legs of 3 and 4 and 5, you will have a right angle between the two shortest sides. Another Pythagorean triple is 6, 8, 10, and we can get to that just by multiplying each digit in the 3, 4, 5 triangle by 2. When we are familiar with these Pythagorean triples, we can use them to our advantage when building stable constructions with our Lego parts. The key is to add 1 to each side of the triple. So if our triple is 6, 8, 10, in order to see what Lego holes we should use, we will add 1 to each one of those digits, and with the result of a 7, 9, 11 triangle. So from the Pythagorean triple of 6, 8, 10, add 1 to each number to get a new triangle of 7, 9, 11. Let's see how that will work in our little construction. We know that we used 7M beams on the sides of our rectangle. So there's a 7 side right there. So I'm going to put a peg on my top. I have my construction sitting on the table with the longer 11 beams flat on the table going horizontally. And I'm putting a peg in the first open hole on the left on the top. Now I'm going to come across from that to the 11 beam on the bottom, and the first open hole on the left, I'm counting that as 1, and I'm going to count until I get to the 9th hole. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's actually the last open hole on the bottom. So we have our 7 going vertically on the left, we have our 9 going horizontally on the bottom, and now we just need an 11 to go on the diagonal to form the hypotenuse of our triangle. And that's where our third 11M beam comes in. So we'll take one end of that beam and put it on the top peg on the left and the other end on the peg that's on the bottom right. Now that we've done that, we have formed a 7, 9, 11 triangle, and if we pick this up, we'll see that we cannot collapse it. It is nice and sturdy. You often find this kind of support in regular construction out in the real world. So that's the end of experiment number 3. We can put this back into container number 3 and pull the parts out of container number 4. In container number 4, we have 2 7M beams, we have 2 5M beams, we have 2 angular beams that are 3 by 5 with a 90-degree angle, and we have 7 connector pegs with friction that I put in my little dish. We're going to start out by making a rectangle similar to what we did in experiment number 3. I'll take my 2 longer beams and put them horizontally on my table with their holes facing up, and I'll put a peg into the end of each beam so that I have 4 pegs sticking up. Once I have those 4 pegs in, those pieces, remember, are horizontal. I'm going to take my 5M beams and holding them vertically, I'm going to complete the rectangle by connecting each end of a 5M beam to the end of one of the pegs that is sticking up. Now I have a little rectangle, but again, if I stand it up and put any pressure on it, it will collapse. So now we're going to see another way that we can add stability to a structure like this, and that is by using the 3 by 5 angular beam. So to start with, we'll just use one of our 3 by 5 angular beams. I'm going to put it on my work table so that the longer leg, the 5 leg, is vertically oriented, and the shorter side, the 3 side, is horizontal. It's at the top and facing to the left. And then I'll take my remaining pegs, and I'm going to put 2 in empty holes on our 7M beam. One will go in the far right empty hole on the top, and then I'm going to skip a hole, and then I'll put the second peg in there. The second peg is actually in the middle hole on that top 7M beam. And then on the bottom 7M beam, I'll put a connector peg in the farthest right open hole. Now we have those 3 pegs sticking up, and keeping our 3 by 5 angular beam still oriented how we had it, we can move it over and put it on those pegs that are sticking up. And you might have to wiggle it around a little bit to get everything to fit. Once you do that, you can see that this structure is now more stable. One thing when we're building is that it's always nice to use the simplest construction that we can. So let's take this apart and see how we can make something that's stable and have, instead of 5 pieces, we can just use 4 pieces. So I've taken all of my pieces apart and I put the little connector pegs back in my bowl. And now I do not need the 5M beams anymore, so I'm going to put them back in my container. And now let's build a similar construction to what we just had, but now we'll just make it with 2 of the 7M beams and 2 of the 3 by 5 angular beams. So again, I'll start with the 7 M-beams oriented horizontally on my table with one above the other. I'll again start by putting pegs in all of the end holes. And then on the top beam, I'm going to count over from the left. There's a peg in the first hole. I'm going to skip the second hole and put a peg in the third hole. And on the bottom beam, I'm going to count over from the right. There's a peg in the first hole. I'm going to skip the second hole and put a peg in the third hole from the right. Now I'm going to take one of my 3x5 angular beams and orient on my table so that the longer side is vertical, the shorter side is horizontal, and it's at the top facing to the right, and it's farthest away from me. The bottom hole on the long side is going into the leftmost peg on the bottom 7M beam, and then the corner hole on the angular beam and the last hole on the 3 side will go into the 2 pegs that are on the left on the top 7M beam. Sometimes you have to pick things up and wiggle them around just to get things to go in. So now our top beam, if you try to wiggle it around, it's pretty stable, but our bottom beam is only being held in at the bottom corner, so it's not very stable yet. But it will be once we add our other 3x5 angular beam. And for that beam, I'll again orient the longer side vertically, the shorter side horizontally, but this time that shorter side is close to me and pointing to the left. Again, on the long side, the last pins on our 7M beams will go into the top and bottom holes of the 5M side, and then the remaining pin on the bottom beam will go into the last hole. So we can put that construction on. And now we have a nice construction, and it is sturdy, and we are using one less part. So that's the end of experiment number 4, but I want you to keep that little construction still on your table and just put it slightly to the left while we get out the pieces for experiment number 5. So those are in container number 5. In container number 5, we have a 5x7 beam frame, a 9M beam, a 7M beam, and 4 connector pegs with friction. I put those little pegs in my small dish. So before we start building something with the beam frame, let's just compare the beam frame to the construction we just made. Now they are both the same width and same length. If you take the beam frame and put it on top of our experiment number 4, you will see that they are exactly the same length and width. So what's different about them? Well, to start with, what we did in experiment number 4 is not perfectly even, and we have some levels that are 2 beams thick and some that are just 1 beam thick. And then the only place that we have available holes is on the top. Whereas in a beam frame, it's all 1 unit to begin with, and not only do we have holes on the top the top being if it's flat on your table, the side that's facing up, but there are holes on all 4 sides. So it can be very useful to use these beam frames to make construction that goes in more than one direction and holds different parts together. We often see these used as connector parts in building robots between the motors or underneath the motors for stability. So now that we've made that comparison, we can take our experiment number 4 and put it back in container number 4. And then we're just left with our beam frame and our 2 beams. So here what we want to see is how we can build in more than one direction on a beam frame. So I have the beam frame flat on the table. I have it oriented so that the long side is vertical. And I'm going to take 2 of my connector pegs and put them in holes on the beam frame top. I'm going to work on the right side. There's 4 holes there. I'm going to skip the top hole and put a peg in. And then I'll put a peg in the next hole. And so then there's 1 empty hole on the bottom. And then I'm going to add the 7M beam to this side. Now the 7M beam is the same length as the side of the frame because it's a 5x7 beam. So you should be able to orient that 7M beam vertically, and then it can fit over those 2 pegs. So now you've built up a surface there that is 2M thick. So now on our beam frame, we're going to add 2 pegs on the side that's underneath where we just added that beam. So you could pick this up, pick the beam frame up, and rest it on its other long side so that facing up you'll feel the flatness of the 7M beam that we just added on the left, and then 3 holes on the right. We'll add a peg in the top hole, skip the middle hole, and add a peg in the bottom hole. And then we'll take our 9M beam and we'll center that vertically on those holes so that we're going to be putting the pegs into the 3rd hole in from both ends. And again, you might have to pick this up and just put 1 in first and then get the other one in. So now you can feel that we're being able to build at right angles here. We have holes that are coming off to the side and holes coming off to the top. We can do much more with this, but this just shows you how you can utilize those holes to build in different directions. So those are just some simple construction that we can do with beams. We'll see even more ways to use beams and build in opposite directions when we get to our unit on cross blocks.